So what can you do with airfare data? So let's dispense with homework 5. I mean, not everything necessarily is bad with homework 5. I sort of insisted, or I sort of pushed something from homework 5 last class. You can see it in the video on the YouTubes. What did we do in homework 6? Is there anything in homework 6 that we can apply to homework 5? Can someone give me an approach, a pseudocode towards building a predictive model when all you really have is a big old database with 3 series of airfare values, I guess 3 destinations of airfare values, but really, I mean, this feels like, this data set feels much poorer to me than the wind data set, right? The wind data set, you at least had 2 values. You could use U's to predict V's if you had to. And in airfare, you only have airfares. And I don't really want to go with airfare last time. I guess we're going. How are we going to arrange that data in our database? What should our time unit be? It's not going to be every 20 minutes, is it? What do you think you're going to do, Mr. Kapitsky? What should the basic time unit of time be in this airfare data set? Because I know some people probably collected their data at 6 a.m. in the morning as soon as they got up, right, Luke? And a whole bunch of people probably collected data right before 2 p.m. every day when they realized, oh, database class is coming, I gotta collect my data. You're probably gonna see a whole bunch of clusters of 2 p.m. time collections then. And otherwise, you might just see random time collections from people who just randomly remembered during the week that they didn't collect data that day. And so sometimes it was in the morning, sometimes it was in the afternoon, sometimes it was in the evening. Sometimes they collected twice in the same day, but as long as there was more than an hour between the 2 collections, that's fine. In general, you gave it time, gave the fares time to change. And so you've got this massive mess of data that's everywhere. You're not guaranteed every 20-minute collections. You're not even really guaranteed that any single person has collected data every day for the Boston flight or the DFW flight. How are you going to process this massive data pile that Michael Owens, not right, the other one, pardon? Howard collected in such a way that even if Caden wanted to do a time series model, that he could do it, because I don't think you can even do that with this data, the raw data anyway, yet. Have we ever seen a method to take raw nonsense everywhere data and then sort of aggregate it to a certain time unit maybe? What do you think, Dalton? No! You only come to class 1 class period out of 10. You better come with some answers when you come.
Can you just use like ImpNo, like we used in the previous days?
Yeah, well, I mean, I gave you that ImpNo value in the wind data. I sort of created it out of 20-minute segments. And that was only because I saw that all of these wind stations across the country, the fastest they ever gave me a reading was every 20 minutes. But it wasn't always at the same minute, and so I just basically had to say, if it's taken between the top of the hour and 20 minutes past, then it'll be 1 ImpNo, and the next ImpNo is from 20 minutes past to 40 minutes past. And so I basically created that out of the raw data of times collected. But and so I needed to know at that point, hey, I can have a different value for every 20 minutes. How can we collect this data together in such a way that we can process it, like give it artificial imp nodes that we can use as hooks by which we can do self-joins and things. What is a good time unit for this data? About how often per day did you collect data, Laura?
Just once a day.
Did anyone else collect data more than once a day? Yeah, on some days, maybe some people collected more, but in general, would you say that on average, most of you probably only collected data on your 3 flights once a day? Maybe not even on weekends, but because if that's the case, I mean, I think we should be guaranteed that at least one reading was collected per day, right?
Mm-hmm.
Let's make the basic unit of time per day. And what that means is we're not going to need to create a new column like ImpNo. We've already got a date column. We can aggregate by date, group by date. Does anyone remember how group by date works? Or group by works? There's an example in the chapter 3, the most recent PowerPoint that I gave you. But it's an additional clause that just tacks on to the select clause, and it only works if you've got an aggregate function.
Doesn't it like expand the table horizontally? Like in the same, it like groups stuff that
Does
has
it?
the same.
Did you say expand?
Yeah, like it takes the.
Yeah, I don't think it expands it horizontally at all. Actually, joins probably do that.
Okay.
Joins make tables wider, have the potential of making tables wider. But yeah, and I remember doing an example of this in class. I don't know if it ever got on a video, but I did it with, in fact, I did it with airfares. If you look inside the PowerPoint for linear regression that's on D2L, you'll see that example. In fact, let me just pull it up here. It may take me a minute to find it, but at least I'll be showing you what I'm talking about while I'm talking about it. Because, I mean, if you're looking for a direction, I think this would be a good direction to start off in. 3507, linear regression. Where did I? Probably in the L's. PowerPoint. Okay, that's where I talked about group by. Okay, so I only have one group by example, but then I started talking about joining tables together, and before joining tables together, I decided to come up with a fares daily table. So a select into example. What is the difference between these two queries? I know that the autumn sunlight is messing with us here with that random angle splashed across the screen, but somebody tell me what that top query is doing. Anybody could copy paste this into their access table, and as long as they had a table named fares 15, or if they changed fares 15 to the name of their actual airfares table in their database, what would this query return? And assuming that their table had these column names in it, so they need their date column to be named DT, which your date column might not be. But probably you have columns in your airfares data named DEP airline and DEP flight number. I believe those are the names I asked you to use at the beginning of the semester. So those should be pretty standard. And I usually don't use the word date in my SQL queries because that tends to be a keyword, not only in SQL, but in other programming languages. And so that's why I shorten those names. And maybe that's a standard name. Does anybody remember? Did I ask you to have a DT column for your date? Did I ask you to have a TM column for your time? Sort of feel like that's familiar to me. So I think DT, DEP airline, and DEP flight number are probably standard. Probably that's what you have in your collected airfares table. And if you don't, feel free to change the column names so they match the queries that you want to run, as long as those names are standard and will make sense for other queries. But what is, I mean, let's ignore this group by line. Let's pretend it's not there. What do the first two lines do?
Just selecting the date, the airline, flight number, and the average fare.
Okay, yeah. You know what? If we're ignoring the group by line, we better ignore the average fare line in the first line, because I don't know what that's going to do. But yeah, if we were doing select date, departure airline, depart flight number from fares 15, what would we get from your collected data in the database that I made available to you for your final projects, which you've surely looked at by now, right? You're probably going to get back 1,000 rows. Every student who's submitted a flight going from Minneapolis to DFW will have an entry in there. There will probably be, I don't know, 500, 600 entries for those things. They've all got different fares. They're all taken on different dates. Some students forgot to collect fares on some days, but hopefully other students didn't. And so most holes should be filled. And so select date, departure airline, departure flight number, and I guess fare. Why not just do fare rather than average fare? From fares 15, we'll return a table with 4 columns: a date column, a departure airline column, a departure flight number column, and a fare column that will have, you know, the details that people collected over the course of the semester, taken out of some table named fares 15. And what group by does is it says, for all of these elements in the group by clause, if they are the same, crush them down into one row. So instead of extending horizontally, this is de-extending, whatever the opposite of extending is. This is crushing down vertically. And the only thing that's not in that's not specified in this clause that was specified in the select header is fare, and if that's surrounded by an aggregate function, then all of the fares on the lines that were crushed away will get averaged into one average fare. What does this do? This creates one line for Delta Flight 1, 2, 3, 4 per day, and it will average together all of the fares that people collected for that flight number on that day.
I wanted to ask about the day, actually, the date and time. How do you compact it just to the day? Shouldn't there be like more to that bit? Because if people have different times throughout the day.
Yeah, but that's why I asked you to put time in a separate column.
Oh, okay.
And so if you do have a CDT column, because I often combine my date and time together for if I actually want to see where things happen during the course of the day. But in this case, I think we want our basic unit to be days, not hours of days, because I can't guarantee that in a class of 14, we had at least one student who gathered at least one reading for every flight destination every hour. I think it's more probable that I can count on students to have gotten one reading per day. Out of 14 students, at least one of them might have gotten a reading on a Saturday. And maybe I can't count on weekends. Maybe we have data for the 5 work days of the week, but we don't have any or much data for weekends of the week. Who, raise your hand, who collected airfares on weekends? Okay, we're probably not going to have too many holes during weekends. I mean, we may not have 14 collections per Saturday and Sunday, but we might have 2 or 3, and so even if we have 1, the average of 1 is still going to be something. And what we like is not having holes in our data, because if we are going to do a 3-point model, every time we have a hole in there, that actually creates a hole of 3 time units in that 3-point model that we can't generate a prediction for. But this is a great first step with that compiled data of all the students, is take all of that data and group everything down by departure flight number and date, and just get one value per flight to each destination. And I mean, some people will have collected Delta flight 1, 2, 3, 4 to DFW. Others will have been following Delta flight 4, 3, 2, 1 to DFW. So those will still be 2 separate lines. And I don't know, maybe that's not what you want. Maybe you want to collect the average of all students' flights to DFW per day. In that case, you're going to be selecting date and average fare from fares 15 grouped by date. And so if we're not mentioning these, then it's not checking to make sure that similar values of those get crushed into their own particular column. You can, if you want, it might be an overly general model, if you don't like having a view of all of the flights to DFW, maybe you can just average together all of the fares going to DFW regardless of airline or flight. Or maybe you can just gather them by Delta flights and Spirit Airlines flights and whatever flights. And that might be a good middle ground, rather than crushing all of these different airlines and their different pricing schemes into one line of data per day. Yeah.
Couldn't you crush the airports, so like MSP to DFW, and crush those together so that you could still get all the flights leaving those?
That's what I mean by DFW. We're only considering. I mean.
Because this is airline and flight number, so you get like Delta flight whatever, when you could just I take all the MSP to DFW ones and get the average flight across all of the different
Yeah.
airlines.
You know what though? I mean that's a good point. Is I'm not if I wanted to make sure that DFW stayed separate from New York City and Boston, I should probably include DEST in here and then group by DEST so that doesn't get crushed away. But I bet that's already encoded in the flight numbers. I bet that you're still going to.
There's not a flight also going to Dallas Fort Worth, the same.
That has the same flight number with the same company. Yes. So I bet this is just barely enough detail to keep that from happening. But yeah, I mean, just to satisfy my own anal retentive worries, I would probably add DEST to both the select line and the group line, just so that I have that in my results, and so that I can select everything from my results that it's going to DFW, say. Because yeah, right now, it's not obvious from these results that I can separate the DFWs from. So even though we're not really crushing away the destinations, we're also not showing ourselves the destinations in this simple little SQL, because I was basically just doing a toy problem with this, demoing that, but your actual SQL probably needs to be, a little bit longer than that.
You don't know the flight, or you know the flight, but you don't know where it's going.
Yeah, and you would actually have to look up, okay, since I'm interested in flight 1, 2, 3, 4, you'd have to look up in the raw data set and see, oh yeah, Delta flight 1, 2, 3, 4 is a DFW flight. But you wouldn't know until you did that lookup. Unless, I guess, you could take this result and join it with the raw data and then get that result back, I suppose. Except you end up with duplicate rows at that point, probably. Create problems with yourself. Probably it's just easier to have destination included in this select header. But okay, so now we know what group by does. It crushes rows down with similar values, and whichever the non-similar values are that are included in the select header, they should be enclosed within an aggregate function like max or min or average. I mean, the only one I've ever used is average. Sometimes max is useful, but probably not unless you care about what the maximum fare is on a given day, which probably you don't. Average is a fine reading, and that gives you one reading per day. And so, okay, we know what this SQL is doing. What does this SQL do? Given that we know what the above SQL does. I believe the bottom SQL is barely different at all.
Yeah, it's just putting it into a table.
Yeah, taking those results and putting it into a new table.
And it's rounding it to make sure it's like the currency.
Oh yeah, okay, yeah. Yeah, I decided that I didn't like that some of the fares had 6 or 7 decimals in them in this table. So, but generally, I play with a query and see the results and then change the SQL and then see those results and then keep on changing it until I like what the final result table is, and then I create a new table out of those results, because this is always a temporary table which disappears as soon as I change the query. And so once I've played with my query enough that it's giving me exactly what I want, then I actually solidify it into its own table, fares daily, which is what I used in that linear regression PowerPoint to demonstrate to you how to build a time series of airfares that you could determine a slope and a y-intercept from. And so I think that's probably going to be a good step for you, good first step for you for this final project here. So if you want to get to the point that Steve was saying, where you have some sort of model that produces predictions that you can make a graph out of, so that you show the original average daily fare for this flight and then the predicted average daily fare from that flight that was using whatever data that you had that was previous to that date, probably. You don't want to use the value that you're trying to predict as part of the prediction. Then your model will just center itself on that thing because it seems to be right so much of the time. And that doesn't make sense to use the value that you're trying to predict to make the prediction. But oftentimes when we're writing code, we don't realize that we're cheating in that way. It's easy to miss that in the process of creating the SQL in the first place, out of all the tests and frustrations and near misses. So yeah. So this is a pretty good example of playing with your query until it's perfect, and then creating a table out of it, and then that's the basic table that you would probably use for each of your 3 models, your predictive models for DFW and for Boston and for New York City. And the reason that I wanted you to do 3 separate models, I mean, you're probably going to follow the same approach for all 3, that's fine. But what I kind of expect to happen for you is you're going to generate this table. It'll probably have more columns than I have here, but and then you're going to submit that table. You're going to copy paste that table into Excel and ask Excel's data analysis regression tool to figure out what the best columns are for the predictions. And then you might even eliminate some of the useless columns, just so you don't have to write out great big long equations to do the predictions. Just use the coefficients for the columns that matter. And I feel like the columns that matter will be different for DFW than they are for Boston. And maybe even New York City's will be different from Boston's as well. I expect them to be different from New York City's. But now that you have this tool available to you that will tell you what your best columns are, you can start with the same 18 columns or however many you come up with for each of your models. But I expect to see that as you refine those models, the best columns will be different for each one. That's sort of what I'm interested in. I'm kind of interested in what makes New York City fairs different from Boston fairs. What should I be paying attention to? But yeah, what I do expect from your teams by Monday is 3 graphs, 1 graph for each destination, the actual data, daily data for each destination, daily average fare data, and then predicted average fare data. Just try to predict the average. Typically, predicting an average is way easier than predicting for a single flight like flight 1, 2, 3, 4. An average eliminates the highs and the lows and gives you a nice cushion to aim for. And so your RMSE tends to be a little bit higher for that. But you do also kind of need predictors. Anybody have any ideas on predictors? Veda, do you remember what I talked about on Monday to use for predictors? If you're going to try to avoid using time series predictors? Do you remember why I said time series predictors were bad, Laura?
I don't think I was here.
Maybe not. Do you remember, Dane? Were you here on Monday?
I wasn't here.
Well, Stephen will remember.
No.
No.
I was here and I just don't remember.
Were you here, Aiden?
Friday?
On Monday?
Monday.
We're Wednesday today, right? We had a class on Monday, right?
Yep.
Yes.
I was here.
You were here?
Yeah.
Why shouldn't you use any previous values as predictors for the fare that you're trying to predict?
I wish I could tell you.
Yeah.
Sorry to disappoint.
Because the linear regression model loves previous values. It will center in on them as the most important thing. And
And
what you're basically
That's how you get naive.
what you're basically creating yourself is a naive model. And I mean, you're creating yourself a naive model just by using the previous predictor. But even if you ignore the previous predictor and then the 2 hours before predictor or 2 days before, and you go with the 3 days before a fare as a predictor, it will still focus in on that. Any time series element will, it's basically following the actual data curve. If the actual data is going up here and then down here, then the predicted data will be a little bit later, but it goes up and down whenever the original one goes up and down. And so mathematically, when we're using the RMSE, they're always in the same area, even if one is 2 days late. And so that always tricks the regression analysis tool into thinking that lagged data is, there's something that lagged data knows. There's something really good about that column there. And it just doesn't have the eyes to see that it's just always lagging. It's always 3 units behind. all Excel sees, all the tool sees is the number, the RMSE, the aggregate value, yeah.
If you thought that there was like maybe a weekly pattern to the prices, like it goes up at the start of the week, goes down at the end of the week, something like that.
Yeah.
Could you do like a 7-day back prediction and then go from there to maybe see what it thinks it'll be like a week ago, if it'll be like that today?
Yeah, you could, except 7 days before will always, I mean, if this is the actual data, and then 7 days, and then after 7 days, this will be the 7 days before data. And so again, if you use raw data like that, the analysis tool is going to say, hey, that thing is always pretty close to where it needs to be. I mean, after maybe 7-10 days, maybe it's getting worse. But you might be safe with 7 days, but I doubt it. I don't know what the period of something like airfares is, but it's probably more on the I don't know that there is any periodicity for airfares, really. Humans tend to buy things on weekends. I bet that there is some big change around weekends, like maybe Friday night suddenly airfares go up because they figure that people are going to start looking on websites and getting fares like that. So,
Or people will want to leave on weekends for trips, so the airfare goes up during ticket spot at that time? Or?
yeah, maybe if we're talking about last minute fares, but I don't know that's going to be particularly huge. Last minute fares are basically airlines putting seats on sale that they want to get rid of just before a flight leaves. So I don't know how huge that is as a driver for fares. But I did mention something in class for people who want to use data from 7 time units ago or 2 time units ago, if they want to. It just can't be the raw data. It's differenced data. Tell me how much it's changed from 7 days ago and use that value as the predictor. And that value is not going to follow the actual data so closely that it looks like a great predictor. But there might be some great information in there about, okay, well, 7 days ago, the data did this, and if every Tuesday the airlines do that same thing, they change the prices, then when that thing happens 7 days ago, then as we're approaching the same 7 day period, maybe that same thing is going to happen again this week. It's like probably the programmers at Delta have set their programs to go through all the fares on Saturday at midnight or Monday at midnight. That's where the whole Tuesday fares are cheaper on Tuesday thing goes. They just have a program go run through all of the fares that they have available, and whichever flights they have more seats on, they make those fares go down, and then any airplanes that don't have very many seats available, maybe they move those fares up. But there are probably certain times during the day, around midnight probably, or certain times during the week where the airlines decide to do things. Maybe not all the airlines are doing those things at the same time. They're all doing it independently, much like you guys were collecting data independently. But if most of our data is from Delta, then any patterns in the way Delta does things could actually help you in your predictions if you were able to capture them in your differences that you generated from this raw data. So when you are creating this table here that you eventually solidify into a real table, probably one of the things that you want in here is the result of a self-joined and then fare 1 minus fare 2 value that gives you a 7-day difference or a 3-day difference or a 2-day difference or whatever sort of difference you think would be relevant. In fact, I would try all of them and let the tool tell you which difference is important. And then when you refine your model, make it the smallest possible table to do your predictions, fewest possible columns, throw out all the useless columns. How do you know if a column is useless according to the data analysis tool?
P-value?
P-value, what does the P-value have to be about?
It's less than 0.5.
Less,
No,
so yeah, the rule of thumb is less than 0.05. You may not have that choice. Sometimes I just choose the three columns with the smallest p-values, ignoring the y-intercept, the intercept row, which is not a column. But you know, if nothing is below 0.05, but I still need to make a model, let's choose 2 or 3 of the best columns that it found out of the 10 or 18 columns that I put together. But it is true that for scientific relevance, if you're going to present your results in front of a conference room of pointy-headed academics, then if you're going to say, I based my predictions on these things, one of the questions they're going to ask you is why? Why did you base your prediction on these things? And a good answer is always because the p-value was 0.05, which is, you know, 95% good, is kind of hand-wavy what that comes out to. And so if you say, because the p-value was 0.6, because that was my best p-value, everything else was above 0.6, that's probably not something you want to present to the pointy-headed academics, because they'll think that's ridiculous. 0.6, 0.4, 0.3, all terrible. You want, you know, the gold standard is 0.05. And if something is really hard to predict, maybe they'll let you get by with 0.10 or something. But 0.20 is just not trustworthy enough anymore to make predictions off of. But for this class, use your best 2 or 3. Was that helpful? Yes.
What predictors are you going to have us use for making our model?
Yeah, that's for you to decide.
Oh,
You get to come up with your best ideas. I'm giving you differences. Differences in pairs probably is all we have. Maybe it's not all we have. What do we have from homework 5? What else did I say on Monday? I think you should use slopes. What is a slope? It's just another kind of difference. But a 3-day slope can be captured from the fair on day 4, 4 days before the day you're trying to predict, and 1 day before the day you're trying to predict. And then day 4 fair minus day 1 fair divided by 3, because it's 3 days of fairs. That's y minus y and x minus x. And I'm never using day 1 fair because I'm assuming day 1 fair is the day that we're trying to predict. And so yeah, come up with a table of slopes, and then you can do differences on those, and now you can throw yourself together a table of 10 different raw airfare value columns, and 10 columns of raw 10 columns of difference slope values, and I don't know if any of those will be any good, but some will be better than others. And it would be kind of interesting, even if we don't know why the 5 difference slope column was better than the others. If it's helping us make better predictions, maybe we don't care. Maybe this is something that's only good during the month of November or September or October when we're collecting the data, but it'll be completely different in spring. But this data for the period that we're covering, we might actually find something seasonal in there. This flight was happening very shortly before Thanksgiving, and there's often something about major U.S. holidays that affect U.S. airfares. And so there might be something about Halloween or Thanksgiving going on in your data. I don't know. I think one of the general trends of your data is airfares do tend to go higher as your departure date approaches. And so if you're using all of this data to predict when I should buy my ticket for departure on that one day, you would, the general conclusion might be buy your ticket as early as possible, because in general, as you get closer to the departure date, it's getting higher. But there might be Tuesdays or weekends when the price goes down, and there might be something that you can get out of that data that gives you a clue as to wait until Saturday to buy the ticket, or buy the ticket before Saturday, because it always takes a jump at that. Any other questions? So on Monday, so no class on Friday, for people who weren't here at the beginning when I said that. But on Monday, I'll expect a procession of, I don't know, 7 or 8 groups to show me preliminary results, preliminary directions, and plans on future directions, but maybe no more than 3 slides. Keep the presentations short, get everyone through in the 50-minute period, and then we'll do a longer presentation a week later during finals week. I'm gonna do it again. I'm gonna keep you guys late. Luke, you know what's going on. Pass one of these out to everybody. Student evaluations. Let me keep you 5 minutes longer. When you're done, you can pack up and leave. Put your sheet, I guess, on top of this folder to turn it in. I'm going to be sitting outside in the corridor because administration doesn't like me looming over your shoulder when you're giving any grades. And whoever is the last one to fill out that sheet, bring it out to me in the corridor. The rest of you I will see on Monday.